Welcome to PART, guys. Welcome to PART episode 3. I'm Justin Chin, studying integrated business and engineering. I'm here with James Wadhwani. He's studying aerospace and he's leading the R&D team. Why don't you tell us about yourself, James?
Right, so I'm James Wadhwani. I am the R&D lead this year. Last year I was the R&D airframe lead, and I'm actually a graduate student, which is kind of gross to say. I don't like saying it. But I'm doing a 4+1 program. So I graduated this May, and then I am just here for a year, and then I'm going off to Lockheed, actually, where I accepted a position recently.
That's really exciting. So when did you get first involved with Purdue Aerial Robotics?
So that was junior year, beginning of junior year. Sophomore summer, I had an internship with Textron eAviation, working on an eVTOL, which is an electronic vertical takeoff and landing aircraft, called the Nexus project. And my friend Dylan McCool, who was one of the actual founders of R&D, he was just a member at the time, he reached out to me and said, "Hey, you should come join us." And I was like, "Whoa, this is just like what I'm working on at this internship, so I'd love to." So then on junior year, I joined specifically R&D. There were very few of us at the time. And then from there, I became airframe lead the next year, and then R&D lead this year.
Cool, James. What does your role as R&D lead actually entail day to day?
So day to day, it's a lot of administrative stuff, which I don't like as much as doing the technical work, the actual engineering work. But it is still very fun, and it's fun to kind of have more of an advisory role now in terms of the actual technical aspects. So for meetings specifically, what happens is R&D meets as an entire group all at once, which is different to how comp does it because they split up into sub-teams on different days. We do everybody on one day, and we meet in one big main room, Physics 203 right now, and we do kind of a before meeting like recap of the big things that have happened so far and what we're doing looking forward. And so I run that, and then everybody splits into sub-teams, and I go around to every room, and I make sure everything's going well, everybody's on the right path, and give any advice that I have. So in terms of meeting days, that's kind of what it looks like. Every other day, I'm scheduling rooms for some reason, or doing any sort of design work that is left over that needs to get done that the leads maybe don't have the bandwidth for. So,
James, how does your team decide which technologies or problems to explore?
It's a good question. So at the beginning of summer, every year, we will have a meeting with the competition team. And we will talk about what technologies they want to see moving forward, what will help them in the actual competition. And then we strike a balance, right? Because R&D has a lot of members, and it's important that we keep those members with solid work that they can do. So I appreciate the fact that R&D every year has been building planes, even though they're more of a research and development team, obviously. So we kind of strike a balance between getting the cool design work of building a plane and also working on those technologies that comp wants to see. So for example, this year we're doing the modular plane, which is an aircraft that can detach all of its components with quick disconnects and then attach whatever sort of technology onto it that you want in order to test what we can see and what we can use in the future.
Right. Can you describe one of the coolest or most challenging R&D projects that you've worked on?
I would say that the modular plane this year is the most challenging and potentially the coolest, depending on how it goes. So last year we worked on V2 called Dodo. So it's the second iteration of a VTOL drone. And the work was somewhat cut out for us, right? Because I came in as airframe lead, and the CAD had already been done the year before while I was a member, and we had to just refine. It was a 2-year design cycle. So that was a project that we were able to take our time with and make sure that we had a product that worked. This year, it's challenging because, first off, we are on a 1-year design cycle. We're trying to match up with competition so that they can better use our technology, right? And also striking that balance between having a modular plane, so something that can fit a variety of wing shapes, mission profiles, and technology that you want to put on it, while also maintaining enough efficiency, to be used for the actual competition if we need, right? In order to have that technology be able to move over to competition easier. So that's a difficult balance to strike, and it makes the actual design of the plane very challenging.
You've worked with Lockheed and Textron. What are some takeaways of hands-on experience that you can actually bring to PART and that you have brought to PART as a leader of the R&D team?
Good question. So specifically for Lockheed this past summer, I'll use that as an example. It's kind of twofold. First off is sort of the leadership skills that I saw there, and being able to apply those to leading R&D. For example, there's a guy named Ed who worked in the wind tunnel, and he was actually the project lead for the project that I was working on during that summer. And so he would come into the wind tunnel with information about how the project needed to go, and he would actually teach us things about how both aircraft design works and what we should be doing in the wind tunnel in order to achieve what he needed done for the project, right? So that's kind of a mirror of my role now as R&D lead, and I'm able to bring in kind of the techniques that he used to teach all the people in the wind tunnel, and a lot of them were relatively new, actually, including, obviously, myself as an intern. There were a lot of newer full-time employees. So the way that he was teaching them was by asking a lot of questions, questions that he knew the answer to, but in sort of a teaching way, in like a learning environment. He was able to keep us engaged and articulate what we knew and what we didn't know through these questions. So I've been trying to bring that into how I lead R&D. For example, at the exploration sessions, I was leading a section on aircraft aerodynamics and stability and control and sizing. And during that, I asked a lot of questions, and I kept people engaged in that way. Instead of talking to them, it was sort of a conversation back and forth. And I think that's a very valuable way to lead, is through conversation rather than direct telling, that I kind of brought in from the internship. Second off is the technical aspect. So I was working in a wind tunnel that summer, and I saw how that actually integrated into actual aircraft design. And now I'm standing up a wind tunnel team through Drew, who's the lead of the testing team. And we're able to use the information that I learned this summer to do the same thing, right? Put an actual physical model into the wind tunnel, see how deflections interact, the coefficients and forces on it, and then use that to compare it to our low fidelity model, our X-Flyer model, in order to see, is it actually accurate? Is this how our plane's actually going to fly once we put all the components on it? So that's an important way. Two separate ways how I'm able to bring things from my internship over to PART.
Right. And with that first way, I remember you telling me how you'd ask questions regardless of if you knew it or not. What is the benefit of asking a question that you already know the answer to? Right.
Well, when I say asking a question, I'm asking it in the way that obviously I know the answer for, let's say, the specific question, but I'm doing it in a way that's meant to engage people, right? It's having been a member, and obviously this summer too, having been the guy that doesn't know much about the design process for Lockheed, it was really engaging for Ed, this guy who came into the wind tunnel, to sit down at a computer, show me a plot or something, and say, hey, how does this impact our flight profile? He knew the answer, but it kept me engaged, and it made me think critically about what we're actually doing. So in the same way, I've been trying to ask people a lot of questions on the team about how the work they're doing is impacting the main aircraft. Because sometimes it's easy to lose vision, right? Lose sight of your component and how that impacts the whole aircraft. So that's what I mean by asking questions.
As R&D lead, how do you handle pressure of leading a very important team, something that's really important to you? And aerial robotics is such a huge interest, just like how playing games, and ranked or anything like that. It's really important because it's so much fun for you. Mm-hmm. How do you handle that sometimes those nerves of taking off or those flight tests?
That's a great question. So it is something very important to me, and I'm very passionate about it. And so I think that the pressure kind of comes as a side effect of that, right? It's building a plane is a difficult thing. It's a stressful thing, and even now I'm stressed about getting prepared for our PDR, our preliminary design review, that's going to be coming up. I think it'll be next week. So this kind of pressure, I'm able to handle through my team, really. I mean, I have a great group of leads under me who have been putting in some amazing work. And they're easy to rely on. I think that's kind of the point of the R&D lead, is to spread out work, right? It's to make sure that everybody's working efficiently and making sure that the stress isn't all on one person, it's on the team entirely, in a good way, right? So I'd say that being able to handle stress through dividing up work, giving it to the leads, and making sure they know what they're doing, and solid communication, which actually I've kind of been finding out recently. Communication is the most stressful part. It's very easy to give people outdated information, even if it's just on a design that's very slightly changed, which leads to the person who's received that information going down the wrong route. So I'd say solid communication and relying on team members is the best way to handle that pressure.
Right. You have mentioned spreading out the work with your team. Who are people that you really can trust and can count on communicating with and trusting with sort of a task that you're giving?
That's a good question. All of my leads, I'd say, are those people that I can trust on. And also there have been a few members this year who have been putting in exemplary work for, getting things done in a manner that we need them done. There was someone on the airframe team who stayed up until 5:30 2 nights ago working on computational fluid dynamics to see the lift and drag on our fuselage, that's a very small component, but the fact that he stayed up until 5:30 a.m. doing this for us is huge, and he's one of those guys that I can rely on to effectively get kind of this work done.
James, what skills do you think are most valuable for students looking for R&D roles or within R&D already in PART? What skills are good to develop before applying for any R&D roles? I know you said it was more of a learning experience.
That's a good question. So, it is more of a learning experience, right? We don't expect any technical skills or knowledge coming in. But if you would like to have technical skills, the skills that we aim to develop coming into it, so you're maybe a step ahead, having a solid understanding of CAD, specifically for R&D, we use SolidWorks. So understanding how to use SolidWorks and how to model something well is certainly a skill that we look for people to have, as well as just an understanding of how aircraft work, right? Aircraft are fundamentally complicated systems. If you just understand what an aileron is, or, how an aircraft rolls, how pitch works, if you have a pilot's license, a lot of people come in with pilot's licenses or starting their training. So a lot of that stuff is knowledge about how an aircraft work, and that's something that we aim to both develop and teach people, as well as, it's nice if you have that coming in, but you definitely don't need it. On another note, on a less technical note, I would say just having the commitment to keep pushing with our projects. Work can be very boring designing an aircraft, right? It's not all sunshine and rainbows, which I found out the hard way, as many people do, right? You think it's all just cool aerodynamics work and wind tunnel tests, but there's a lot of boring things that go into designing a plane. For example, a mass spreadsheet is something that I spent hours on last year. So that was literally finding every component in the plane, measuring its distance from the center or from a origin in a coordinate plane, and finding its mass and putting that in a spreadsheet. And we had hundreds of items on the spreadsheet, which for a mass spreadsheet, that's not even a lot of items, right? For an actual plane, there are millions. So there's a lot of boring work, and I'd say just having the commitment to push through with getting that work done and get to the fun stuff is something that we can't really teach, and something that I certainly look for in members.
James, what brought you to aerial robotics in the first place? What drew you to aerial robotics? As a kid, were you interested in just planes or anything like that? Oh,
yeah. I think I watched Top Gun too many times. Honestly, that sounds cliche, but I've always loved planes. I got my pilot's license in high school because I loved them so much. And, I thought that it was more of a, free thing back then, in terms of, you could just fly a plane wherever you want and you don't have to learn much. But doing that pilot's license actually taught me that there's a lot of technical skills that go into even flying a plane. The radio work, for example, is very difficult. You have to talk to a lot of people. So that kind of woke me up to the realistic aspect of what aviation is like. And that actually made me want to be an engineer because I started liking that technical aspect of it. So then I came into Purdue as an aerospace engineer. I had seen PART before. Actually, Corey, who used to, I think he used to lead competition, he was in my AEE 251 class, and he was on my team. And we just joked about stupid stuff all day. But I saw a PART sticker on his laptop, and that's when I first heard of PART. And then, as I said before, when my friend Dylan McCool, invited me to join, I was like, I've already heard of this club. This is exactly what I want to do. And going into junior year, I joined it. So
that's really cool because Corey was actually on episode 1 of PART.
Oh, cool.
So I actually got to listen to him speak, and you saw the sticker on his laptop, correct?
Yep.
That's really cool. Is he the same year as you?
Yeah, he is.
Is he still at Purdue? Is he a grad student?
No, he's graduate. I don't think he's in grad school.
Got you. Cool. James, if you could give advice to a student interested in R&D, what would it be?
I'll say this before and I'll say it again. Sticking through the boring work, right? There's a lot of boring work that goes in aircraft design. I don't mean to make it sound boring. It's not a boring process overall, but there is just kind of that nitty-gritty work that needs to get done.
Right.
There's a lot of learning that needs to get done. I learned a lot from joining PART that I didn't know through my classes, even as a junior and senior. Mainly it's learning how to apply things, but I digress on that. Being able to stick through a design to the end, even if you get dissuaded by things that are happening, maybe a design changes, maybe you have to redo your work, which has happened to me before, and I know it's happening a lot with the modular plane design we're doing. If you just stick through it, you're going to go far. Virtually all the leads that I brought on this year are the people who stayed until 1 a.m. when we were doing our manufacturing, right? They're the people who just stuck with it when it was a difficult day. I remember there's a guy named Timber. He actually dropped out of college to go explore the world, which is crazy. He's a French guy we had on our team last year. I love him. He's a great guy. And there was one time when I think it was 1 a.m., 1 or 2 a.m., and we were in the composites room over at PTC, and we were trying to do a layup to reinforce our foam wings. We had built them out of foam. And it started, since we had the spar holes already cut out of the foam, it started crushing those wings. And Timber, this guy, was there, and he was like, okay, let's just put some wax on wood sticks and push them through and stop it from crushing, you know? And he stuck with us that whole time, even when I was ready to quit, when it started crumpling. I was like, I'm done. He was still there, and he was still ready to go. And unfortunately, now he's off having fun, you know, not doing college. So I'd love to still have them on the team, but it's that kind of stuff that I look out for. Is people who stick with us, who are always ready to help, and who like are there when we need it. Right, 1 a.m. when we're manufacturing. That's going to take you places in life.
Right, the passion of 1 a.m. sticking in the lab and just to keep going regardless of if you're tired or not. That's actually Isha's. I asked her about her funny story, which I'm about to ask you right now, but most of her good and favorite moments were actually in the lab at like 3 a.m., just sort of doing what you love at the same time, messing up and laughing at the same time.
Yeah.
So what are some funny stories you can share with us?
Probably my favorite story is after Dodo's first crash. So Dodo uses a controller called ArduPilot, which essentially takes the pilot's inputs and puts it into something that is suitable for the plane and its flight attitude. So, for example, if you didn't have a controller and you pushed a stick all the way to the right on your remote, it would roll the plane, right? It would keep rolling. It wouldn't stop rolling. We fly in a mode called fly-by-wire A, which essentially takes that command and it limits it to a degree. You command a degree, not a roll rate, right? And so if you are a full stick to the right, then your plane's only going to bank 30 degrees, and it's going to stay there. And then when you put the stick back in detent, it'll go back to 0. So all that to say, we had the controller, ArduPilot, we had the gains on that set wrong for our elevator. So that means when we pull back on the stick, there wasn't enough elevator deflection because the controller thought, oh, we only need this much to take off. That was not true. So the first time we tried to take off, full throttle, plane goes down the runway, full stick back from our pilot, and it just flew off the runway, level, smashed into the ground, right? Never pitched up. So after we repaired it, we were all sitting in PTC wondering how the heck can we test whether or not we get enough elevator deflection. So actually, first off, we took a shop vac and we connected the hose to the outlet so that it was blowing air. And then we put a 3D printer spool over it so it constricted the airflow so we could get up to the speed of air going into the pitot tube that we'd be taking off at. And then we had someone on the stick controlling it. But then Parker, our avionics guy, was like, well, it may not just use the pitot tube to measure that. We actually don't know if it uses our GPS to estimate a speed and it combines that with the pitot tube speed or what. So then I was like, okay, let's go stick this thing in a car. So we drove down the road at 30 miles an hour. Parker was in the back with the actual controller in his hands, pitching the plane up and pitching it down. And I had the tail section out the window with both arms. And we were going 30. It was like midnight or 1 a.m. It's always 1 a.m. in these cars.
Oh, it was 1 a.m.
Yeah, it was late. And we were we were driving down the road with this tail sticking out the window. And he was in the back controlling it. And so we were going 30 miles an hour. And from that test, I could see that it had enough authority to at least move my hands, which is much more authority than we had on the runway. So I could tell that something had changed and we had fixed a problem, which gave us just enough information to go back out there and test flight again. And it worked the next time we tried. So.
Was that fun testing it and like going 30 miles per hour with your both
yeah,
of your
it
arms?
was fun. People thought it was stupid. It was probably a stupid idea, but it worked. So I'm gonna take that as a win for me.
Yeah,
so
exactly. Thanks so much for your time, James.
Thank you, Justin.
Tune in for the next episode, guys, and thank you guys for watching. I'll see you in the next one.